Yes, students, we are continuing from where we left off the last time. So I'm sharing the screen with you, lecture slides with you. Okay, so let's come back to this program, which we've seen last time, and we've discussed new concepts there, like declaration of variables, which you can find here. We're declaring 5 variables, one called FHRs and Celsius, and also lower, upper, and step. As we've noted, all statements should end with a semicolon. That's fine. So in this case, your variables are integers. So the keyword to use in C to declare a variable as integer is int. That's something you need to recall now and use. Later, when we modify this program to make the variables become variables which can store decimal point numbers, then we're going to use a float for floating point numbers. Float as a keyword to declare variables. So we'll come back to that later. So and the other new concept we've seen in this program is a while loop. So I'll be explaining that a bit in more detail shortly using some other C codes. So I'm just going to illustrate that. And also we've seen the printf here, which is quite new to what we've seen with the Hello World program, where we just had a fixed text which we're displaying the Hello World, but now we are trying to display the value of variables. So we're using format specifiers. So I will also discuss that. So what I'm going to do now, I'm going to shift to the dev C++ C programming environment and illustrate these 3 new concepts. The first one being a variable declaration and assignment. Second, using the printf function from the stdio library. I had a file to print the values of variables, and finally, is a while loop. Okay, so I'm shifting now to the dev C++ programming environment. So I'm just sharing the screen with you now for the dev C++ program environment. So we've seen that the programming environment already. This is where you're going to write your code. So as I explained earlier, you go to new and then you say source file. So this is your editor here where you can write your program in C syntax, and then you can start compiling and running. So we've done a very simple example for Hello World. Now let's try to first illustrate what is variable declaration. So let's just write a small, simple program. So I'm including again stdio.h because most likely we're going to print the values of these variables, and we'll be needing the printf function, which is found in stdio.h. And then, like we said, you would need to have a main function always. So this we're using the font slightly to get more space on the editor. I think this should be fine. Yeah. Okay, we have been opening a brace for our main program. Now here we're going to start off by declaring some variables. Let's say we want to declare 4 variables. So first one is I, and J, and then it. So a very simple program here. This line is saying here, if I just put a comment here. So here we are declaring integer. Okay. Now, once you've declared, of course, you can start using these variables to store numbers, but you should be careful. You can't store numbers which have decimal points. Yeah, because they are integer numbers. They can be just a minus number, a negative number, that's fine, but cannot have decimal numbers. Yeah, so it could be like 1 here, something like this, and J is equal to 2, let's say, and then K is equal to 10. So with here, this line was declaring the integer variables. Now these lines are actually defining or assigning values to the declared variables. Same thing for I, J, and K. Now this part explains very well. So if I compile and run this program, it's not going to do much. It's just going to not going to show anything on the screen. So let's try to do that first. So I'm just first going to save it. Like I've said earlier, you have to save it as a .c source file. So the type of file is .c, and then just put a name here. I'm calling it variable declaration. Okay, variable declaration .c, and then you save it in a folder where you have access to. If I compile this program, a very simple one, it's giving error 0, warning 0, and if I run I'm not going to see anything on the screen here. Like I said earlier, this is a point where maybe your antivirus should just do a quick check, so that might take a bit of time the first time you run the code. So let's just wait a bit of time. So currently, this is what I'm saying on the screen, the black screen. Yep, so there's nothing to show here because this program actually doesn't print anything on the screen. Okay. Yeah, so as you can see here, I hope you can see the screen. So it's not providing anything, it's just pressing key to continue. So we've not printed anything. This program is simply declaring some variables. Okay, so let's go back to our dev C++ environment now. And so next, what we want to do now, we want to print the value of these variables. So we know we have to use the printf. We have to use a printf function for that. And the syntax is of the double inverted commas that you have to put, and put the first one to put the second one for you, depending on the version you're using. Okay, so let's say we want just to put a when the program starts, we just want to put a message. This program declares integers and print their value. So this is just like not really comment, is part of the program definitely, and this is going to print on the screen this message. As this program declares integers and print their values on the screen, and then here you would want to change line, so you could change the line here, or you could also next time here say printf, and then here you can change the line in front of it. So when you come to this second printf here, after printing the first line, now it's going to print the line. Now let's say we want to print these three values I, j, k. So we need to put here a syntax that's actually taking the values of I, j, and k. If I put I here, j, and k, these are not the variables I, j, and k. They are just strings. They are just text messages. So I could do like this. I could say the value of I. Then I need to put the format specifier. So the format specifier here is used to tell the printf function that actually I'm going to take the value of an integer variable which is defined in program. So this first percentage d here is for I, and then the second percentage d is for j, and the third percentage d is for k. Now just to remove a confusion, I'm going to remove I here, the j, and the k. Because these were just text messages. So at this point, I just want to say yes. I'm saying to printf here, I'm going to print the values of three integers, percentage d, separate them by comma, the space here, and a second integer, a comma, and then separate it with the space again, and then the third values. Then after the inverted semi, the closing double inverted commas, and I need to put now the values, the variables which I want to print. So this first percentage d is going to be I, then it's going to be j, it can be k. Okay, then of course you have to end it with semicolon. So if you run this program here, we expect to get 1 to 10 at the on the screen. So let's just run this. Let's compile and run this program. So first we save. Compile, so 0 errors, 0 warnings, and then let's run it. So again, could take some time based on the antivirus. So let me just share the screen to you. I don't think you can see the screen at this point, so I'm just going to share the screen what is showing on the screen. Yeah, so this is what the screen is showing here. This program declares integers and print their values. This is what we had the first printf, and then 1, 2, and 10 is being displayed. These values are for I, j, and k. But you can see here the 1, 2, and 10 are just not very informative. We don't know what they are actually. So let's close this one. Press it to continue. Close this one. So it will be more useful here if you actually say what are these values. So if I put an I here, and then j, and then k. So again, I want to stress on that the I you have put there is not actually the variable I, it's just a message you are sending to printf. The percentage d actually is the placeholder for the I. The I value is going to be inserted here. So when you print now on the screen, you will find I column, and then the value would come there, comma space, and j column, then the value will be taken from j to put here, and finally k, same thing. So let's run this one now and see what you get. Let me share the screen again with you. Okay, so this is what we get on the output screen here. So now a bit more informative. We know that this is the value of I, the value of j, and the value of k. Okay, so very interesting here. The new concepts we discussed. Let me just summarize that again. With this simple program here, we've learned how to do a variable declaration. So we've declared variables of that integer, and the keyword is int. Once you've declared, you can assign values to them, and you can print the values using format specifiers. So for integers, you have to record is percentage %d, and so on. Now, next is use the same program here to declare numbers which can store decimal point numbers. So what would happen here if I wanted now to declare integer point number variables which can store decimal point numbers? The keyword is float for floating point numbers. So let's say now we want to declare other variables. Let's say x, y, z. So x, y, and z now. We comment. So we are now declaring floating point numbers. So these numbers can store decimal numbers. Yeah, decimal point numbers. So they can store decimal like 1.5 and so on. So we'll do small test later in the program where we'll try to save a decimal port number into an integer. We'll see that first the compiler can complain depending on the program environment you're using. It can complain. If not, it's just going to throw away all the decimal numbers. So we'll do that at some point. At this point, let's first start with it. So this one can store now a number like 5.5, something like this. And if your y would be a number, so 6.78. And your z, let's say it is 100.75. Okay, so we put these numbers here. Let's start to print their values now. So we do a separate printf now for the floating point numbers. So again, we change the line first, and just like we've done, so we're going to say x now. Now the format specifier you would use for floating point numbers is percentage %f. I hope that's quite straightforward to remember. And then for y, again, it's going to be percentage %f, the second value you want to print. And finally, z is again percentage %f. Then, of course, after the closing double inverted commas, you would want to put the name of a variable. So it's x, y, and z. These are the values of your floating point numbers. Let's run this program now and see what you get. So again, in new concepts we've introduced in this program here is a floating point number. You have here the float keyword is for declaring variables of floating point numbers so they can store decimal point numbers. Okay. And once, of course, you have declared, here you are actually defining, just like we put here. So now you're giving values to them or assigning values to them, and here you're printing the values. So again, x, y, and z are not actually the variables, it's just text to tell us what are the values. The percentage %f here are format specifiers used to tell to printf, yes, we want to print the value of a variable, which is a floating point number, and what are these variables? So x, y, z. See very carefully, the variable names actually come after the closing double inverted comma in the printf. Okay, so let's save that and so compile with no errors. Let's run that. Wait for some time. I'm just going to stop the share again and see what do we get. And now show you the output screen. Yep, so this is what we're getting. The initial one is IJK, that's what we had. Now look at this one. X is 5.57000. So it can see here by default is printing 6 decimal point numbers, 6 decimal places, 6 decimal places, and 6 decimal places here as well. But now we're able to print floating point numbers. Now you can of course modify your, just like in Excel, you can specify how many decimal points you want to have. After the decimal point, how many numbers you want to display, that can also be added to the format specifier. We'll come back to this later. So what's interesting here is we know now how to declare integer variables and floating point variables as well, assign values to them, and print the value on the screen. Let's move on. Now, there's nothing which prevents you from, in the same printf statement, you can print, of course, integer values and floating point values or any other type. So let's try to do that now. If you wanted to print everything on the same line, okay, say you wanted to print the value of x here with percentage %f, Then you want to print the value of I, and then J, and then let's say here you want to print the value of Y. So of course is percentage F. And finally, after K here, you will want to print the value of Z, put percentage F again. So you have to be careful what format specifier you're using for which variable. That's important. Because we know X is a floating point number, so percentage F for it. I is an integer, so percentage D. J is an integer, percentage D. Y we know the floating point number, so percentage F. K is an integer, so percentage D. And Z, of course, it was a floating point number, so you use percentage F. The order you want to operate now is very important. So first one was X, so we're going to put X first. Next one is I, that's fine. Then J. After J, we get Y. After Y, we get our K, and finally we get Z. If you print that, everything will appear on one line. But what I want to show for this program here, there's no issue in mixing format specifiers in the same printf. There's no need for you just to show it in a separate line. You can do it on the same line. So we've compiled with 0 errors and 0 warnings. If you run now, so I'm just going to share it with you now, and your screen with you, the output screen. So what do we get now? As expected, so you get the first value of X in 6 decimal places, and then the value of I in integer, J integer with no decimal points, and then the Y here with 6 decimal points, and then K integer, and then the Z finally. Yeah. So I would encourage you to do practice these codes we're discussing now to familiarize yourself with this, and of course to get the concepts clear. Now, next thing I want to do now is, what if you try to put 1.5 here, or 2.7 and 10.9 here? Okay, so let's try to do that. So we've actually declared I, J, and K to be integer numbers, integer variables, and we're trying to store a decimal point number in it, which is not actually possible because an integer would not store decimal point numbers. But what do we get? Let's try to run this program and see. Now, be careful, we're still printing your I, J, and K as percentage D, percentage G because they're integers, but we're assigning a floating point number to it. So there's a compiler actually complain, no, it actually goes through. There's no errors and no warnings. In some compilers, it could have flagged out this to you that I, J, and K actually declared as integers and you're assigning a floating point number to it. But in this one, it's not done it. So I would say it's not an error. It would flag it and warning to you, but still run it. So let's see what do we get on the screen. Okay, so remember what we did for X was of course a floating point number, the value will be the same, but for I we had used 1.5 and we're getting 1, so that's thrown away the 0.5, and it's not rounding up, it's just throwing it away straight, just taking out the decimal point. Remember for J we had assigned it to 2.7, so it's just displaying 2 here, so again it's throwing away the 0.7, and the value of K we have put 10.9, it's just 10 here, so it's throwing away the decimal point. So this is very important. You have to be careful what type of integer, what type of variable you're using for your variables, and this can have implication on your code. Okay. Now, last thing I want to discuss here before you can understand the program we are using to convert diverse file natural sessions to while loop. Okay. So I'm going to do a new program now. Okay, so again, I'm just going to include your stdio.h because we will definitely be printing things on the screen. Right? Okay, and then as usual, our main program, and then opening curly braces. So I'm going to do something very simple. So I want to declare 2 variables. First one is I and J. Okay, so I want to start. I just want to print the values of integers from 1 to 10. Let's say I want to print the values from 1 to 10. So I would start I at 1 and I want to end 10. So this is what I'm just putting in my code. But of course, you could have not used J here. You could have said I use 10 itself. But in doing it in this way, it means you can, I'm just going to put a comment here. You can see it's the starting value of integer to print, and this is the ending value of integer to print. Okay. So the appeal, the benefit of actually using variables like this is you don't actually need now, if you want to change these values, you can just change the values at the variables and have a comment for it instead of changing the value in your code. So if these values of I and j need to be used at many places in your code, then just changing them at one point makes sense. If you have to change at many places, it becomes error prone. Okay. So let me again explain what we're trying to do here. We want to print the values of integers from 1 to 10. Okay, so we've put two variables here. I is a starting value of integer and j is ending value. Now, of course, we need to iterate because I want to print 1, 2, 3, 4, 5. So we need to have a repeated loop here, which actually increment the value of I by 1 for each increment and print its value. Okay, so the while loop can be used for that. So what I'm saying here, in the while loop is going to iterate whatever statements you have attached to it as long as the condition the parentheses remain true. So what I want to say here, as long as the value of I is less than or equal to j, opening curly brace including, so whatever you put here is going to be attached to the while loop. This is what's going to be iterated many times. So what are we saying here in this line is as long as the while loop condition here, as long as I is less than or equal to j. So currently I is 1. So when the while loop steps in, the first check will be is 1 less than or equal to 10. That's true. So what we do here, we simply say printf. It depends what you want to do. If for every printf you want to change the line, you can say printf like this, and you can say the value of I %t. This is where we are using for my specifier here because the value of I is not fixed, it's being changed within the while loop. So this is where we use for format specifiers because for every iteration the value of I will be different. You're saying print the value of I and change the line for every printing. This is what the slash line is doing. And of course, here after doing the printing, we want to increment I to 1. So we are to say y I is equal to I plus 1. Yep. So this line is incrementing the value of I by 1. So if you currently starts with a value of 1, it checks 1 is less than or equal to 10. It prints the value of 1 and then goes here incremented 2. Now you do 1 plus 1 is 2, and then the 2 is overwriting the previous value of 1. And then you check again, is 2 less than or equal to 10? Yes, that's true. So you do it again. At some point, when you reach the value of 10, so you're going to check, is 10 less than or equal to 10? Because the value of j is not being changed inside the while loop. It's staying fixed. So at some point, you would get that 10 is less or equal to 10. Yes, because you have equal to sign here, but still true because 10 is equal to 10. It's going to print the value of 10. And then when it increments the value of 10 to 11, it's incrementing by 1. You're just going to say here, 11 is less than or equal to 10. That's false now. It does not include anything here. And then if you want to see here, it's print and ending program. Okay. This ending program statement here would be executed after exiting the while loop. This printf is not part of while loop. It's very important to understand. Let's try to run this piece of code here and see what do we get. I'm going to call it while loop.c. Yep. So let's compile. So 0 error, 0 warning. And let me just show a new share to you, just show you what the output screen. So this is what we're getting on the output screen here. So we're putting the value of I, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then when I becomes 11, it does not actually print the value. So very interesting piece of code here for you to implement and try to code. Is very simple. Yeah, but very powerful to understand how the while loop is working. So again, here we've talked about variable declaration. So we're using integers here. We have used format specifiers, and again the while loop here. And this is new for us. It's very important to understand that as long as the condition is checking inside the parentheses, the while loop is true, it's going to just keep carrying out what is written here. Now, for example, if I say here plus 2, so this is going to increment it by 2. So what happens here, it will start with a value of 1, and then it's going to print 1, 3, 5, 7, 9. It won't print 10, so it's pretty easily odd values. Yeah, so these are variations you can just check as your code. So I'm shifting back now to the lecture slides. So I hope this code now makes better sense, makes more sense now based on everything we've discussed. Yeah. So what I've asked you to do now, because we've discussed all of that, I would encourage you now to go and check this one here. So I hope you've done this one, labeling the first time the while loop is executed as iteration one. So on the paper, I want you to do a program trace. So iteration one, what are the values of a different variable? So you can do that on paper and to understand better how the code works. And this is where I stopped last time. So can we take the difference and then multiply by 5/9? So when you're writing this line here, I would ask you to actually take FEHR minus 32 and then multiply here by 5/9 in parentheses and see what you get. In this case here, we are doing 5 multiplied by FEHR minus 32, then divide by 9. But what if you take the 5 here, put it here, and then put a multiplication sign? Okay. So I would encourage you to do that and see what you get. So the aim of today's session was for you to really grasp the new concept we introduced with a variable declaration, with a while loop, and also with format specifiers in the printf. The next video, I'm going to actually start with this problem which I'm saying here, changing the formula to calculate Celsius. If you put 5/9, what do you get? But before I do that, I would want you to test it first and try to understand what actually is the problem in, if any, in the code when you actually take 5 divided by 9 first and then multiply by FHR minus 32. So I'm ending this video here. The next video I will send would be on this topic here. Thank you very much.